Hello, this is going to be my video on arithmetic sequences, the recursive function. Last week we looked at an explicit function which can find any term. Now this week we're going to see this recursive function which is weaker because it can only find the next term. And that's kind of what this word recursive means. It means looking back at the thing before it. So if I look over here at our formula already, one major distinction I need to make sure you know. Yes, we have the nth term again. But this right here, this is not n minus 1 like we've seen in the past, where we plug in and we get a number. Now this is f of n minus 1. This is a term. And since it's not the nth term, it's the one before that. So I'm going to say it's the previous term. Sorry, I spelled that wrong. Previous term. Or if you want to say the n minus 1th term, you can go with that too. But yeah, dang it, man, I'll just fix this. Previous. Okay. For a recursive formula, since all we're saying is that we've got a term is equal to the previous term plus the change, then we have to always say what the first term is. Or else, if we just said the term plus is going up by 10 every time, it wouldn't matter unless we knew where it started from. So we got the nth term is equal to the previous term plus the change, and that's it. So if you look at this, we only have to find two things here. So that might have been confusing, but let's just take a step back and look at a couple examples. So remember, just like before, we're still just going to focus on finding two things, f of 1 and d. So as long as you can still find d by taking a term minus the previous. So if I do that here, 8 minus 5 is equal to a nice 3. And my first term doesn't take any math skill, I just have to locate it. It is 5. So now I'm going to make my recursive function by writing the first term. And then, look, this part never changes. I'm just going to keep writing f of n is equal to f of n minus 1 over and over again. The only thing that I need to put in is d. So even if I started this problem and I knew I needed a recursive function, I could always just start with the fn is equal to f of n minus 1 and then add in the change afterwards. So if I go back over to my second example, so this is it. As long as I say f of 1 is equal to 5, and f of n minus 1 plus 3 is equal to f of n, I've created my recursive function. So once again over here, I've got my first term. So when I say f of a number, f of n is the nth term, f of 1 is the first term. That is 30. And d is, here I see that is going down by 5, so I'm not even going to do a formula to find that. And then I'm going to represent my first term is 30, and the function is a term going down by 5 every time. So the recursive function is really one of those annoying math I have to interpret it things, but as long as you can still find your first term and your d, that's literally the only thing I'm putting in every single time. First term, d. First term, d. Nothing else changes. It's actually more simple than the explicit function once you get a hang of it.